All right, today we're going to be working on 7.8, graphing functions. The instructions here tell us to graph the function. When you have a homework assignment or a quiz or a test, it's just going to say graph the function. It's not going to give you the domain, okay? Our previous assignment that we did yesterday, it said the domain was -2, -1, 0, 1, and 2. For this, it's just going to say the instructions I have up there, graph the function. You just want to remember we're going to do 3 points when we graph. Just kind of like when we did our line graph before, we just did 3 points. We're only going to graph 3 points for this, and we'll use -1, 0, and 1 as the domain. So the first problem we have today is y equals x plus 4. All right, so I pulled up a piece of graph paper here. As you can see, the domain. Is the domain my x or my y?
X.
It's the x, okay? So just like we did yesterday, we are going to be plugging in for the x. So we have 3 points that it has asked us to plot. So I'm going to rewrite my original equation 3 times so that I can plug those in. So what we're doing today is we're kind of building on what we did yesterday. We are going to be finding what the x and the y are. So I'm going to put an x in a box, a y in the box, and then I'm going to find out what these are. In my instructions, it already told me what the x was, or what the domain was. What is my domain? What 3 numbers?
-1, 0, 1.
-1, 0, and 1. Okay, so just like we've been doing, we're going to plug it in. We're going to put in a substitution. So I'm going to get rid of this x, and I'm going to plug in what it has asked me to do, -1, 0, and 1. So we have input the x, or we have input what the domain is, and we've got something that comes out. What comes out for the -1x? What would it be in the y?
3.
What is -1 plus 4? 3. What is 0 plus 4?
4.
What is 1 plus 4?
5.
Okay, so once again, what you want to do is you want to kind of look at this right here and see if there was any kind of a pattern that you did from each number. What pattern did we do?
3, 4,
Plus 1.
Plus 1, okay? So we added 1 to each one. 3 plus 1 is 4, 4 plus 1 is 5. So that's kind of a way to check to see, okay, that looks like it makes sense. Now the difference is we're going to go kind of one more than we did yesterday, and we're going to make an ordered pair. Do you remember when we graphed before we did an ordered pair? We put it in parentheses. -1 was the x, 3 was the y. So go ahead and make an ordered pair for each one so that we know exactly what we're going to be graphing. Now the difference from what we did today versus what we did yesterday is we just have to graph this ordered pair. So you can kind of see my x goes from -1 to 1. My y actually doesn't have any negatives, and it goes all the way up to 5. So we're going to kind of draw here a coordinate plane. So once you've done that, then you're going to want to go ahead and label. As I go to the right, it's going to be positive. As I go to the left, it's going to be negative. Remember, do it on the lines so you can easily tell what that line is.
Are you supposed to put like A, B, C or something?
And then when you go down, just remember you're going into the negatives. The first ordered pair that I have, what does it say?
-1.
-1, 3.
-1 and 3. What comes first, the x or the y?
The x.
The x. So labeling over here, my x. Is my x left and right or up and down? Left and right. So just remember, this is your x, this is your y. You can't really see that. As I look at this, my x comes first. So do I go left and right first or up and down?
Up and down.
Left and right, because that's the x. Everybody put your finger on the origin. The origin is 0, 0, so you're starting at the origin. I have to go to a -1 and then up to 3. So you just remember, you always start at the origin, go left to -1, and then up to 3, and put a dot. Now beforehand, we would have labeled that dot, point M, point F. We don't have to label dots because we're graphing an entire function. Who would like to come up and show me where 0 and 4 is? We always start at the origin. What's the origin, guys?
0.
0, 0. Okay, so my point you're going to do first is 0. So where do you move for a 0? Nope. You don't move. If it's a 0, you do not move, okay? So the X doesn't move. So keep your finger on that origin right there. And now you're gonna go to 4 for the Y. Do you go up or down for a 4? You go all the way up. So where are you gonna go? All the way up to there. Very good job. Who would like to do my last one? All right, Kayla, come on up. So here we have, you start at the origin. Guys, where's the origin? 0, 0. Now you're going to go over to 1. Okay, you went to the right one, and then you have to go to a 5. Do you go up or down? All the way up there. That is correct. All right, so now all you have to do is you have to draw your line, connecting the points. So it's like connect the dots. Okay, and that is your arrow, or that is your graph that you plotted. Going that way and that way. Okay, so that is how you graph a function. Let's go ahead and do another example. Y equals negative 3x. So the instructions here are graph the function. It doesn't actually tell me what the domain is, but we know every single time it tells me to graph the function, what's my domain going to be?
Negative 1, 0,
It is the x, and it's going to be negative 1. What are the other points?
0, 1.
Excellent. So we're just going to write it because we know there's 3 x's. We're going to go ahead and rewrite that equation 3 times. Now we'll set up our x and our y. I know it's going to be negative 1, 0, and 1. And now just plug in that substitution. Instead of putting the x there, I'm going to plug these numbers in. But if I have a number right next to a letter or a variable, what am I doing to it? What operation? Multiplying. Okay, then I want you guys to go ahead and find your range. First thing, my x, I input a negative 1. What comes out? What's my first y? 3. Negative 3 times negative 1 is 3, because when you have 2 negatives, it equals a positive. What's negative 3 times 0? 0. And the final one, what's my last y? Negative 3. Great job. So now we're going to make sure we've got our ordered pair. These are the ones that we're going to be plugging in. So all you're doing is you're taking those exact points right there and putting them into parentheses to show me what your ordered pair is. What I want you guys to do is go ahead to the right and draw a coordinate plane. Okay, once you have your coordinate plane there, now we're just going to plug in the points. The first one right here is the first ordered pair I'm going to do. What are the points that I have there? Negative 1 and 3. When I go negative 1, do I go left and right or up and down? Okay, so which way? Left or right? Okay, so you're always going to start right here. I'm going left, negative 1, and then where? And then up to 3, okay? So then I know this right here is my point that I've got to be at. You go left, always start at that point of origin. Left 1, up 3, plot your point. Next up, what is my next point that I need to plot?
At the origin.
Okay, do I move anywhere? No, just keep it right there at the origin, okay? Because it's 0 and 0. My final point, what is it? 1 and negative 3. Who would like to come up to the board and show me where it goes? Okay, come on up. He started at the origin, he went to the right one, and then he went down negative 3, okay? So now you have plotted all of your points, and you're going to go ahead and draw your line, connecting the points or connecting the dots. Then put your arrow at the end showing it could continue to go up and continue to go down if we plotted more points. Does this look like a line?
Yes.
Yes, it looks like a diagonal line that's very straight.
They don't have like.
All right, go ahead and write down these 2 definitions for me.
These need to be in red.
These are 2 things that we're going to want to know. A linear function is a function whose graph is a line. So just to kind of give you an idea, like this. See how that's a line? Okay, it's a line. Do you see how this is not a line?
Yes.
Okay, so this one right here would be linear. This one right here would not be linear. Okay, so then the next thing is a vertical line test. When drawing a vertical line, is a vertical line an up and down line or a left and right line?
Left and right.
It's up and down. It's just like the Y, okay? So when drawing a vertical line anywhere on the graph, so let's say that I draw it like this, it means it will only touch the graph one time. Now the graph is just this part that I drew in the red. The graph is not your coordinate plane, okay? So when I drew this line up and down, how many times did it touch my red line?
One.
It only touched it one time. So this one right here is a function. Now let's say that I draw a vertical line. Once again, is a vertical line up and down or left and right?
Up and down.
Up and down. So I'm going to draw my vertical line up and down, okay? It is a function if it only intersects the graph one time. How many times did I intersect my graph?
Twice.
2 times. It went right there and it went right there, okay? It intersected twice. So this right here is not a function, all right? So go ahead and write these instructions down for me, please. My instructions here say, tell whether the graph represents a function of x. The way that you can tell if something is a function is by doing the vertical line test. Look back at your notes and read to me, what is a vertical line test?
In drawing
the
a
drawing
vertical
of a
line
vertical
anywhere
line
on the graph, it is a function if it only intersects the graph one time.
Okay, so I'm going to go ahead and draw a vertical line. You can draw this anywhere. Vertical, is that up and down or left and right?
Up and down.
Up and down. So once again, I'm going to do it right here on the left-hand side. All right, a vertical line, just kind of draw it. It's like a dotted line, okay? How many times did my dotted line touch our graph?
Once.
It only touched it one time. So if it passes the vertical line test and it only touched one time, it is a function. So you're simply going to write the word function, okay? If it's not a function, you'll write not a function. So then my instructions say, if it is a function, tell whether the function is linear or nonlinear. Do you see a word in the word linear?
No.
Line.
Line. Linear means line. Nonlinear means
No line.
not a line, okay? Is this right here linear or nonlinear?
Linear.
It is linear because this is a line. And then box in your answer. It's a function and it is a linear function. So let's look at the next one. You're going to do the vertical line test. My instructions ask, tell whether the graph represents a function of x. A vertical line test. Is it up and down or left and right? Up and down. Okay, for this one, I'm going to go to the right of my y, just because I feel like it. How many times did my line touch the graph?
Twice.
Where did it touch it twice? The only time I see it is it touched right here. Did it touch on my graph anywhere else?
No.
It doesn't have to do with if it touches your x and y. It just has to do with if it touches your graph. So did it touch my graph one time or more than one time? Only one time. So is this a function or not a function? It is a function, so you're going to write the word function. Now you have to tell if it's linear or nonlinear. Is this a line, guys?
No.
No, it looks like a U. Okay, so this is nonlinear. Box it in. I've got one last example. Remember, my instructions say, tell whether the graph represents a function of x. How do you tell if something is a function? You have to use what test? The vertical line test. So take and anywhere there, make a vertical line, go through it. How many times did I touch my graph?
Twice.
Twice. I touched it right here and I touched it right here. So is this a function?
No.
No. So you're simply going to write not a function. Now, if it's not a function, you actually don't have to decide if it's linear or not, but if you look at it real quick, can you tell, is that linear or nonlinear? It's nonlinear because it is not a line. And that is everything that you need to know today for 7.8 graphing functions.